Okay, good morning. My name is Manuel Fahndrich. I work at Microsoft, and I'm going to talk about the project called code contracts. So what are code contracts? I would describe them as a way to express preconditions, postconditions, and invariants in your code, and a bunch of tools that take advantage of these specifications. You may be familiar with other approaches, for example, spec sharp, or JML, or Eiffel, which also provide you ways to express specifications and have tools that check them at runtime or statically. But one of the major differences here is that this is not a new language. It is just a way to provide this for any .NET language. And the tools also don't care about what language you're using. So how does this look? Here's some C# code for an add method. And in green, I highlighted a precondition, which we express by making this sort of idiomatic call to contract.requires. And then you just give a Boolean expression, in this case, of course, in C#, that says this is the condition I want to be true on entry of this method. In this case, we said, the argument value should not be known. In orange, you see some postconditions, that is, things that should be true at the end of the method. And let me highlight some of the features here. So I already mentioned that you use the language you're writing in this case C# for the conditions. And the good thing about that is that you get all the things you're used to, namely your IDE is going to make sure you're typing in correct stuff. It gives you IntelliSense or completion and so on, right? Think about using attributes. You wouldn't get any of that. And not only does it do that, it also checks that your stuff is semantically and syntactically well formed. The postconditions are written at the beginning of the method, not where you might expect, which is at all the return points. And that's because, first of all, you don't want to repeat them everywhere. That would be silly. And the second thing is it's part of the interface of this method, namely just like the return type of the method is declared at the beginning, like in this case int, so you can look at the header and you know what this method is about. You also want the postconditions to be a part of the header, essentially. You don't want to have to go through the body and find them, right? So everything is declared at the beginning of the method. And yes?
I wonder how we implement this.
Yeah, we'll get to that. Of course, I'm setting you up here. We need some ways to express things that you don't usually have in your language. For example, referring to the result of the method or referring to the value of some expression in the pre-state of the method. So old value of count here really refers to the value of this count property on entry to the method. But you want to refer to it, at the end. So that's some features that you usually have in languages like spec sharp or Eiffel and so on. Another thing you can do is you can specify object invariants, that is, things that should be true about your state at all sort of public method boundaries. And you can do that by specifying a separate method and some attribute on it. Now, so this was C#. Same thing can be written in VB. And note, in this case, the expressions that you write are, of course, VB syntax. And the VB compiler is going to check that this thing is usable. So this is good because you don't want to learn a new language just for writing some pre- and post conditions in your code. All right. So what are those static methods that we're calling there? So these are really just markers in a way. So we have this static class that we define in the library, and in CLR4.0 it's going to be part of MS Corelib. And as you expect, they would just take a Boolean condition, and they don't do anything. And we use those as a way to mark what parts in your code are the contracts. And then the tools are actually going to post-process that. So I'm going to show you how that works. But I just want to point out a couple of things that I think are important about what we're doing and why we're doing it. So we really want to write specifications in one single form and then use them for many purposes, right? I mean, the first and foremost use of what you're writing down is as documentation, right? You need to write something that someone else can actually understand, or you can produce nice HTML from or something like that, right? Because we all need to know what our interfaces are. So documentation is first and foremost. And second one, these contracts should be executable so that you can do testing, right? It will help you, make sure that your code does what it's supposed to be doing when you're testing your code. And also, the contracts should help you when you try to do static verification or try to do a static bug finding. So there should be the same form of contracts for all of these. You don't want to have 3 different languages you have to do this in. So that's important. And another point is, well, why not just use assert, right? Assert is already there and so on. People use it. But there's a couple of problems with it. Assertions are typically not understood as a contract between 2 different parties, right? The method contracts I've showed you are really between the caller and the implementation of the method, right? And it's important for blame assignment to know that. Whereas an assert is just something a programmer puts in for himself. It's not necessarily something he wants to be visible to someone outside calling the code. And they're also difficult to tool again, so we need some standardized way to express these things. Okay, so enough slides. Let's go and do a demo. So here's some C# code that contains requires here saying that the argument should be non-negative and that the result is going to be non-null. So it's taking an integer, returning a string. Now, if we just build and run this, let's see what happens. So I'm going to go step into this method. We just skipped over this stuff. We return, nothing happens. Okay, so why? Well, these methods that I showed you, these markers, these static methods, they're conditionally defined, okay? And if you don't enable anything, well, nothing is going to happen. They're just no-ops, right? So let's actually, enable contracts. And to do that, we have added a contract pane to the properties. And here you can enable, in particular, static checking and runtime checking. So let's do the runtime checking. And let's step again through the code, see what's happening now. So I'm going to step in. And now we're going to evaluate the requires, just like we would expect. And then we skip over the ensures because that doesn't make sense at this point, right? We want to check that on exit of the method. So we step through, we get through this case, we end the method, and now we're going to do the ensures. We're going to check whether we're returning the right thing. And of course, in this case, we don't. So we get a message that says, well, the post condition failed. You need to return something that's non-null, right? Now, another thing to note here is that the string here that you see in the exception is actually the string in your code. But you didn't have to write that string yourself again, which is silly if you'd have to do. So the tools can take advantage of that. All right, so that's sort of the simplest kind of thing. But let's do a little bit more. Let's see, well, what about object invariance? Say I have this data field here in my object, and maybe I want this data field to be never negative, right? So I could say, I could add an object invariant method, and I have a little snippet here that lets me do that. So I can say that the data field should never be non-negative. And now let's just step again, see what happens. Now this time I'm going to step into the constructor where we initialize the field. Right, and now, we're going to go into the object invariant check and check this right here. And it's not correct. We initialized it to something wrong. So in particular, we initialized it to -1. Okay, and we get a failure, as expected. So that's silly. Of course, let's fix that. But the good thing about object invariants is that, well, they have to be true everywhere. And so in this case, I'm finding some other violation. So let's look at the call stack, see where this is. I have another method called update, which assigns this field. And now automatically, because I wrote an object invariant, I'm going to be held to that here too. And in fact, every method you write, you would be held to it. So, and that's called from here. Oh yeah, obvious bug. Let's fix that one too. And so we should be good. So that's preconditions, postconditions, and object invariants for you. Now, let me quickly switch over to do some static checking, just to point out how that looks. So that is triggered also by a build, essentially, and it runs in the background, and it gives you messages as you are sort of used to from a compiler. So in this case, it says, well, if you really have this invariant that data should be non-negative, then I suggest you have a precondition on this constructor that says that the argument should be non-negative, right? So maybe init should be non-negative. And similarly for the update method, it says the same thing. So let's add that too, to make it really explicit to the caller in this case that that's what we want, right? And then it also, of course, points out that this method here that we ran through before, well, it really doesn't uphold its post condition, namely that the result is non-null when you go through the default case here. So let's fix that. And let's rebuild, see what happens. So now it's happy because, we fixed all the problems. And of course, if I left one of these bugs in here at a call site, now that I have these preconditions on update, you'd be warning me about that, of course, saying, hey, this is not good, and here's the requires you're violating. Okay, so that's just a quick run through of this simple demo. Let's go back to the slides and show you exactly how this actually works. Yeah, questions?
Can you also specify the contract in interface?
Yeah, that's going to be exactly the next demo, but let me just go through some details before, yes?
How are exceptions and the insurers?
So are you talking about, yes. Yeah, you can also specify an insurers on a particular exception subtree and say, if any of these exceptions get thrown, this should still be true. Yeah. Question?
Can the compile time analysis produce errors instead of warnings?
It could easily do that. We didn't want to break your build by producing errors, and that's why they're warnings.
I think SpecSharp did that.
Yeah. I mean, it's an easy option. We just didn't want to break the build. That's all. Okay. So here's our example again from the earlier slide with the requires and ensures, and the blue is just the normal body. And as I showed you in the demo, when you just do a normal compile without enabling anything of our tools, you just get the body without any of the checks, okay? If you enable the tools, we define an extra symbol that now includes all these marker methods and their arguments. And so the IL, which I don't expect you to read, is just sort of a structural view of what's getting produced by the compiler, will contain, the expression of the IL to evaluate your preconditions, the IL to evaluate your postconditions, and then the method body. And now this, of course, is not something you want to run, right? Because the ensures is in the wrong place. We call this a declarative form. So that's not what you saw running. So that's when the tools come in, right? So we have a IL rewriter, which instruments your IL to perform the checks in the right place. So the first thing it does, for example, is it looks at your post conditions and it sees whether there's any old values used, that is, values from the pre-state. Well, in that case, it needs to save those away at the beginning of the method, okay, after checking the preconditions. And then you run the body, and then in the end, you check the post conditions and you refer to these saved away values, right? But not only that, it does much more. It inherits contracts from, say, interfaces or abstract classes or other base classes. It checks whether the contracts are well formed with respect to certain properties you want. And it also extracts the source of the conditions from your source text and sticks them into the generated IL. So that's all nice, but how does that work across assemblies, right? I mean, usually I'm not just building one big DLL. I'm working with libraries, and not all of them are mine, and so on. So if you build a library, you might want to ship your bits in a form that don't contain any contract or very minimal checks, right? Even though you yourself, maybe during development, used a lot of contracts, right? So as I've shown you before, it's easy to not have your contracts in your shipped code. But now you want your clients of your library to take advantage of your contracts, right? Maybe you have interfaces with contracts or other things. And in order to do that, we automatically generate what we call contract reference assemblies. These are assemblies that look like your thing you're producing, but contain only the contracts, not the code, Okay, and you can ship that separately, and the tools can then combine those things again. So if someone builds against your library, they can see all the contracts. Now let me show you in a demo how that works. By the way, so these contracts reference assemblies are just generated by stripping out the blue part, right? Essentially. All right, so I've prepared a little interface here to show you how you can write contracts on interfaces. So here's a interface trim suffix. It has a method which is supposed to trim some suffix of a string, and of course, because it's an interface, you can't write the contracts the way I've showed you before directly in that place, because there's no code you're allowed to write on an interface declaration, right? And so what we have to do is use a little device, and we have to write a contract class for that interface. And we usually use the naming convention that we just use the interface name added with contract. And now here, you just implement this method, and that's where you specify the contract. So in particular, we specified here that the source should not be null, the suffix should not be empty, and that we're going to return something that's non-null, and that doesn't end with the suffix. Okay? And the way that we link those two things are simply with an attribute. So, so on the interface, you say contract class. The contract class for this interface is this other type, right? And that's how we know that's where the contracts are. Okay, so I prepared this in a different, separate assembly here. Now let's go and actually implement this in the code here. So I'm going to try to implement this. And okay, how do we do this? So we could say, well, if source ends with suffix, let's remove it. Substring 0 source length, oops, minus suffix length, and then return to source. Okay, so something like that. Now, I'm not sure if I did everything right. Oh, actually, I'm still running the static checker. Let me just switch over there. Let me show you a tool by a colleague, Pelli, which is essentially a test exploration tool. It says, well, if I click here and say run PEX, it says, try to make this code fail. Any way you can. Try to make it fail. And the good thing is, because we're using this mechanism of rewriting the IL, the contracts get automatically inserted from the interface specifications that I had and help this test exploration tool to find ways to fail this code. So in this case, it found 5 test cases, 4 of them which pass. And let me point out that if the test case that it tries to generate, in this case, passing, say, null as a source, that test case is not flagged as a failure because you're violating the precondition of the method, so it's not expected to work, right? And similarly for the passing null for the suffix. But it found 2 cases that work fine, where if you have a 0 character and you want to trim it and you get nothing back, that works, and so on. But here's one case it found where it doesn't work, which is what if you have 2 0 characters and you want to trim the 0 character, then the post condition that is not satisfied is that, well, it still ends with the suffix, right? It still ends with the string that's the 0 character, right? So our code is not quite right yet. We need to do a little bit more. In fact, this should be a loop. That is, we want to repeatedly remove the suffix until there is no more suffix, right? And now, if we try to test this code again, PEX will no longer be able to find a counterexample to the contracts. So that's how interface contracts work. But it gets even better, because these contracts are still pretty simple, but you can write something a little bit more involved. So here's a trim suffixes, which takes a whole array of strings that you want to trim. Okay, And now the contracts might be a little bit more involved. Now you need to write something that says, well, for all elements in sources, I require that none of them are null. And for all, and the suffix well is still the same, but then for the result, well, on the exit, I want still the elements to be null, and none of them should end with the suffix, right? So we have this for all, which is simply a little helper that makes sure that some condition is true for every element in an enumerable, and then we use the nice C# syntax for closures to express our condition. Yes, question?
Am I limited to parameters here? Or?
No, you can use anything you want, anything that's accessible. There are certain rules about what should be used in contracts. For example, should be visible. Preconditions should always be visible to the caller, right? So you can't say something about your private state in a precondition because the caller has no way of satisfying that. But in postconditions, you can say pretty much anything you want.
Aren't they executed inside the context?
Yeah, but it's documentation. And it does not make sense to document that some private field needs to be 5 when I call your method because I don't know anything about your private field. So that's not a precondition. That would be an assertion in your code. But other than that, yeah, you can say anything you want. So now you can see that if we do this kind of thing, this whole runtime instrumentation actually gets quite involved because you need to. These are closures, so there's some closure types, there's extra methods. We need to copy all that stuff around, make sure it works in the context where you're inheriting this into. So it gets a little bit more involved. So let's go back to the talk and point out a couple more things. So the nice thing about, I think what we ended up with is that the contracts that, the contract format of these reference assemblies is really a nice format because we didn't have to invent a new format. It is already well defined by the ECMA standard, right? So we didn't have to invent any new instructions or anything. It's just IL, and if you need to know what it means, you can just look at the ECMA standard. So, for example, if you use equals in your conditions, well, if I have to define what equals mean, that could be quite tricky. However, if you just look at the IL, well, there's some fixed interpretation that the compiler gave to it, and that's what the meaning is going to be. And so I think that's really good. It's a uniform format that tools can take advantage of. And there's already tools out there to read it, so you don't have to invent something new. Just a couple of words. So the static checking, and actually the runtime checking too, when they run, they need these contract reference assemblies for things you reference, right? Just like in the example I have in the demo where I have this interface library, and I need to know the contracts of that so that I can inherit them. And the static checker, of course, needs to know those too. Couple words on the static checker. It's built on CCI, which is sort of an infrastructure that you heard yesterday about by Herman Venter. And we basically, we start with just reading the assembly, and then we build higher and higher level of abstractions. So, for example, at this level here, we insert, we make all the contracts into assertions and assumes. So an assert is something we have to prove. Assume is something we get to assume, right? And there's some extra tricky things for referring to old and manipulating the evaluation stack and so on. And then we just raise the level of abstractions further and further. We remove the heap by producing a scalar program. We recover some expressions. And then at the very top, we just have a bunch of analyses that compute fixed points over abstract domains, for example, numerical or non-null arrays, and so on. And then we have proof obligations or any of the asserts that are in the code explicitly, or maybe we can enable some extra things you want to check. For example, maybe you want to check that there's no null dereferences, which would be implicit assertions in the code. So working at the IL level has some pros and cons. The good thing is it's well defined, as I said before. There's a standard. You can just look into each instruction what it means, and there's a small number of instructions to deal with compared to, say, dealing with a full language like C# VB, F sharp, and so on, right? So that's a big advantage. And the other advantage is that all the work that the compiler does, namely all the name resolution and typing and overloading resolution, all these things, you don't have to worry about because it's already done. If you work at the source language, you have to worry about all these things, and you have to get it exactly right, and that's you don't want to duplicate all the work that the compiler is doing, right? But it is also tricky because you're working at this very low level of abstraction, right? So you need to recover some of the expressions that were in the original code, and you need to understand certain idioms like that are not encoded in the IL as higher level constructs like iterators or closures, which just become funny classes and methods and objects. Okay, and so these tools are available at the website. Actually, I can show you that. On DevLabs, there's a place where sort of experimental or evaluation software is available from Microsoft, and so it can be downloaded there and try it out. There's several licenses, one for academic purposes and one for commercial purposes. And I'd be happy to answer more questions. Yes?
What about IntelliSense integration?
Okay.
That would be really interesting that in addition to showing method signature.
Right. And we're working on trying to get the standard doc comments, generated XMLs, to include the contracts, and then IntelliSense would actually pick those up too, right? Because I think it all feeds from the same place. But we don't have that integration yet. So we try to not have to go too deep into, for example, existing tools. So we have to change no compilers, right? In the IDE, we had to change nothing except our extra pane where we can enable certain things. But we didn't have to go deep into any of the editors or anything. We didn't touch those. So we want to sort of stay away. But I think there's ways to get what you want without having to, go deep into integration issues. Yes?
Do you support for like loop invariance?
Yeah. So. For example, if you want to statically check the trim suffix method I showed you, you have to help the checker a little bit. You have to write an assert in the loop, and that will be enough. Then it will both prove it and use it, and it will say, yeah, it's good. But if you don't, it fails to guess the proper invariant at that point, yes.
The invariants, when do you check them? On entry or on exit?
We check them, dynamically we check them on exit of all public methods only. Yes, and constructors.
So you might not catch an invariant early enough.
That's right. Yeah, it's tricky with invariants, and we just had to make some choices.
And for the ensure stuff, what happens if you put it at the end?
It doesn't work. No.
So it's not recognized by the tool.
No, it has to
be.
No. No, the tools will fail. I mean, you don't want it to be in the. It doesn't make sense to have it at the end because. For the reasons I said before, it needs to be declarative. It needs to be something you can find. And second, it might refer to the result, which is just a dummy method returns you 0 or null every time you call it. It's not interpreted until the tools run. And third, it might refer to old stuff, which again does not get saved away until you use the tool. So it's not something you can use without the tools. And if you use the tools, it has to be in the right spot.
Yeah, it's debatable. But I have a question. The result type, if I put the wrong type.
The compiler doesn't know what you're doing anything wrong, but the tools will tell you that's the wrong type. That's just a problem of the languages that we use don't have inference for return types. Yes. Question over?
Do you put conditional attributes on any of the contract methods?
Yeah, they're all conditionally defined. That's how you get, if you don't enable anything, you get nothing.
So the static checker, does it work for any language?
In principle, yes, although there's certain idioms that you have to recognize that are sort of specific to languages, and we are currently getting up to speed on F sharp, so it's not yet quite there, but it's something that is relatively doable, yeah.
The tools that you provide, are they available outside of Are they usable outside of Visual Studio?
Yes, they're all command line tools, and they're integrated in MS Build. So if you just use MS Build, they work, and you can just call them directly as well from the command line.
Yeah, they're DLLs that you can call from your own project.
Yes, they are.
Do you know of any plans to integrate, to provide language integration in post-2010?
So the question is about language integration.
Do you see
Right. So, well, Mike and I have been on the Spectra project before, and I think one thing we learned is that it's very difficult to get a language, to create a new language and make it real, because there's a lot of stuff involved. People don't want to change languages. So what this is all about is trying to do something where we don't have to have buy-in from all the languages initially, right? And if languages want to provide syntax for this, hey, it's easy, right? They can just emit exactly what you would write otherwise, and everything works just fine, right? So I think it's a way to first provide the mechanism and infrastructure, and then languages can opt in if they want to provide nicer syntax for it.
Is it possible to call it explicitly from my code? Before let's say I have third-party library which provided the contracts, and just to be very careful, before calling the object method, I want to call explicitly the requires.
So the question is whether you can call the requires explicitly. Then the check in your code, if you want to check for the requires explicitly, should be the check of the condition, right? If the requires says, x has to be greater than 0, then your check should be x greater than 0. It has nothing to do with calling some existing requires.
No, I mean that there is a target method, and I want to put in my code the explicit code to its requires. Is that kind of thing possible?
So you're basically saying, without knowing what it is, I just want to make sure I'm satisfying it?
No, I know what it is, but make sure, I'm satisfying. Can I control it at runtime from my code?
No, you just have to explicitly write the check that there is.
I think what he's saying is he'd like to be able to check the contracts without calling the method.
We don't generate a separate
Oh, I see.
So basically, as a syntax checker or just a checker functionality.
But so the static checker will, of course, try to validate all the preconditions in your code. So if you
The static will not cache.
you're talking about the dynamic checking, right? You want to call the requires explicitly somehow. So you're saying, I want to call the requires of this method M.
Yeah, before I call it explicitly.
No, you can't do that. No.
I mean, it makes sense when you have complicated assertions where you don't want to duplicate the code.
Right. But then you're doing sort of.
It's a design point of view, and the author of the library should have put a more complex routine.
Right. The way you do that is you provide a helper of a predicate, right? It says, well, you have to satisfy this predicate before calling me, and then someone can call that predicate, right? You can say, if pred true, then I call it. Otherwise, I don't. That's up to the library designer, because you want to.
It's there as a contract.
No, the issue is that you want to. These things need to be something. It's, as I said before, don't think of it as aspect-oriented programming that just does cool stuff at cool points in my program, right? It's first and foremost it's documentation, and if it's not understandable what you're doing, and you don't understand what you're doing in your code when you call this method, because you just say, I'm just gonna whatever it needs to know.
Right. Save me something. Yeah. Let's say if in the future they change the contract or whatever, I want to be sure, and I want to be very careful because it can break something in my system. So before I call it, I make sure that I satisfy the condition and produce my own message. I couldn't call it because
it's a scenario that we don't support right now. Yes.
The static checker, when you put the contract on an interface, so you don't put any code and you put the post condition should be null, does it skip those?
Sorry.
It should validate the static checker should find out that the contract you put in your interface.
Oh, no, so the interface, so you're talking about the contract class for the interface, right, where we specify just the contract. Right? Well, that thing is not checked, right, because it's just a placeholder. Right. So yeah, of course, the static checker is going to ignore that code. It doesn't look at it. Right. It's just going to use the contracts whenever you actually implement this interface.
One question. When you have a contract violation, you have the possibility to continue the execution?
Yeah, so right now we don't really make any sort of policy decisions about what happens. You can fully customize what the behavior is at runtime for a failure. You can provide your own methods that get called, for example. Yes?
Does the contract exception provide an indication of whether it was an invariant precondition?
Yes, it has a little enum. Okay, I think we should probably stop here. We're already over. Please catch me in the back if you want to see more demos or have more questions about it. Thanks.